Hello everyone, welcome back. In this video we will learn Theorem 1.6 and Theorem 1.7 of real numbers.
Video we will learn Theorem 1.6. Statement says let x be a rational number which is in the form of p by q such that the prime factorization of q is of the form 2n into 5m. So the prime factorization of q is 2n into 5m. Here the prime factorization is given where n and m are positive integers. Then what we have to prove here is that x has a decimal expansion which terminates. What are the terminating decimal expansion? I have explained in last video. You can go there and watch. So the last theorem that we have to prove that the prime factorization is in the form of 2n into 5m. But this theorem is the converse of theorem 1.5. Here we have to prove that it has terminating decimal expansion. So let's begin with an example. Okay, so p by q. Let's take some number. For p it can be 8. Then for q it is given that it is in the form of 2n into 5m. So here we will take 2q into 5 1. Okay, so 8 will be like this only. 2 cube is equals to 8 into 5. Okay, so 8 by 40. Now what we have to prove is that this has a decimal expansion that terminates. So we will divide the 8 by 40. 8 divided by 40. Okay, so 40 zeros are 0. 8 will come. We will put a decimal over here. Then it will become 80. Then 40 into 2 is equals to 80. Okay, so decimal expansion is equals to 0.2. This only we had to prove here that it has a decimal expansion that is terminating. So we have got the decimal expansion that is terminating, that is 0.2. 1.7 says that x is a rational number and it is in the form of p by q such that the prime factorization of q is not of the form 2m into 5n. So the prime factorization of q is not in the form of 2m into 5n. Then here we have to prove that x has a decimal expansion that.
Let's understand this by an example. Let's find the terminating decimal expansion of 1 by 3. So we will divide 1 by 3. 3 zeros are 0, 1. Okay, 3 threes are 9, 1, 0. Then again 3 threes are 9. So this will keep on repeating. So instead of writing whole, we will write here 0.3. Then we will place a bar on 3. This shows that 3 is repeating. So here we have got that it is non-terminating. Now we will see in this example. So we will divide 5 by 11. 5 by 11. 11 zeros are 0. Okay, then 5. We will put a decimal. It will become 50. 11 into 4 is equals to 44. 60. Then 11 5s are 55. Then again 40. Sorry, it will be 50. Then again 11 4s are 44. again it will become 60. So this will keep on continuing and we will get 0.45 bar. It will not stop, it will keep on continuing. So this bar shows that it has a decimal expansion that is non-terminating recurring. So this only we needed to prove that if q is not in the form of 2m into 5n,
then the decimal expansion of the rational number will be non-terminating recurring. This was all about Theorem 1.6 and Theorem 1.7. To see my upcoming videos, kindly subscribe my channel.